Hello everybody and welcome back. Today I'd just like to do the third FRQ from the 1998 AP Calculus BC exam. So we're going to delve into some real BC topics today, that is Taylor series and Taylor polynomials. So starting out, we have let f be a function that has derivatives of all orders for all real numbers. Assume f of 0 equals 5, f prime of 0 equals negative 3, f prime prime of 0 equals 1, and f prime prime of 0 equals 4. Part A tells us that we need to write the third degree Taylor polynomial for f about x equals 0 and use it to approximate f of 0.2. In part A, we are asked to write the third degree Taylor polynomial for f and use it to approximate f of 0.2. So to do this, we're just going to use the standard form for a Taylor series, and then we're going to end it at the third degree. So just to quickly recap, a standard form for a Taylor series would look like this. I'll write at the bottom, we have f of x equals f of a, our center, plus f prime of a, x minus a. And I could write to the 1 power over 1 factorial, but I don't think that's necessary, plus f prime prime of a times x minus a squared, so that would be the second degree, over 2 factorial, plus, and I'll just write one more term, f prime 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 of a, x minus a cubed over 3 factorial, plus dot dot dot. We know that our center will be 0 because, just quite obviously from the problem, they give us the most information about f from 0. So that is the information we will use, and they ask us to write a Taylor polynomial for f about x equals 0. So let's just do this. We have t sub 3 of x equals, and then the first term of f would be 5, or f of a. The first derivative is negative 3, so minus 3x. I could write x minus a, but since our a is 0, I don't need to include anything like that. Otherwise, I might have to write like x minus 1 or x minus 3, depending on it. Next, we have our second derivative, and this is 1. So we have plus x squared over 2 factorial. And then we have our third degree derivative, which is 4. So you have plus 4x cubed over 3 factorial. Now we're asked to approximate f of 0.2, which is approximately t sub 3 of 0.2. And this equals 5 minus 0.6 plus 0.2 squared over 2 factorial plus 4 times 0.2 cubed over 3 factorial. And that does it for part A. In part B, we are asked to write the fourth degree Taylor polynomial for g, where g of x equals f of x squared about x equals 0. So this is just really simple. All we have to do is substitute x squared into our Taylor polynomial for f, and then end the Taylor polynomial for g, where we find our fourth degree. So we have g of x equals f of x squared, which is approximately equal to p sub 4 of x, which equals, and now I'm just going to look at the problem from part A, where we wrote out the Taylor polynomial, the third degree, for f, and I'm just going to substitute x squared, and I will stop where I find that I have written the fourth degree. So I have 5 minus 3, and then substituting x squared, and then I have plus x squared squared over 2 factorial. And this is it. This is the fourth degree Taylor polynomial for G, because our last term has the fourth degree because x squared squared is x to the fourth. So if you'd like, I can just rewrite this a little more simply. So we have equals 5 minus 3x squared plus x to the fourth over 2 factorial. And that does it for part B. So now part C. Write the third degree Taylor polynomial for h, where h of x equals the integral from 0 to x of f of t dt about x equals 0. If I want to do this, really, I'll just integrate the terms of the Taylor series for f of t, and then what I will do is I'll just chop off my new series that's been integrated where I need to for the Taylor polynomial for h. So if we have f of t equals, and I'm not going to write the general term here, I don't think it's really that necessary, equals, how about, and then just using what we had from before, 5 minus 3t plus t squared over 2 factorial plus 4t cubed over 3 factorial plus dot dot dot. And now I'm going to integrate from 0 to x dt, both sides. And what will we get? We will get h of x equals, and now something just to keep in mind is that as we're integrating this, because we have a polynomial essentially with an infinite number of terms, when we evaluate our integrated expression at the lower limit of integration, that would be 0, we are going to get 0. So all we really need to do is integrate these terms in our minds and then substitute in x. So we will have 5x, and then we will have minus 3x squared over 2 plus x cubed over 3 times 2 factorial plus 4 times t to the fourth over 4 times 3 factorial plus dot dot dot. And now we are asked to write the third degree Taylor polynomial for h. So I'll just write that h of x is approximately, how about we use, just always use t again, t sub 3 of x, which equals 5x minus 3x squared over 2, and then plus x cubed over 3 times 2 factorial. And this is our final answer for part C. Part D. Let h be defined as in part C. Given that f of 1 equals 3, either find the exact value of h of 1 or explain why it cannot be determined. So, by definition, since h of x equals the integral from 0 to x of f of t dt, we know that h of 1 equals the integral from 0 to 1 of f of t dt. Cannot be determined because the Taylor series for f is not given and cannot be derived. And we see this to be true because in this problem they give us f of 0, f prime of 0, f prime prime of 0, f prime 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 of 0, but we are not given a series and we are not given a general term of f of x. And therefore, we cannot integrate a Taylor series for f of x, and we can also not integrate f of x itself since f of x is not given. So, therefore, or I should say f of t cannot be integrated and evaluated. And that is the end of the 1998 FRQ number 3 from the AP Calculus BC exam. I hope you enjoyed this video. If you did, please give this video a like and subscribe. If you didn't, please show this video to somebody who will appreciate it, and I hope you have a wonderful day.